Hide. I'm a little out of practice. My pen's going to be in good shape, though. You ready? Okay, so Malik, what's cosine of theta equal to based off of our last question in the quiz is using the zero product property? Look at how nice the pen's writing now. Although I just had to write theta twice there. Cosine of theta equal to? Nope. So you set cosine of theta minus 1 equal to 0 and then add 1. So what's cosine of theta equal to? 1. 1 over, by the way, we're getting this ready now. 1 over 1. And then what's the other cosine of theta equal to if I set this equal to 0 using the zero product property? So imagine 2 cosine of theta minus 1 equals 0. Add 1, divide by 2. 1/2, okay? All right, so now we got to go back to this. This is testing your skills on that last thing. What letter over what letter? Tell me. And it's actually both of them, right? So I can go ahead and handle that. Let's go back to this tougher one. What does that mean y has to equal, just to make sure I don't make a mistake? Not 1, because 1 squared plus 1 squared doesn't equal 1 squared. 0. So we got to get that one down. This has happened quite a bit the last 2 days because we do remember these are the harder ones. Students mess this up all the time. So no plus minus. So what is the one spot where you get 1 for x and 0 for y? Where's that located on a coordinate plane in degrees? 0 degrees. And that literally is one of my answers. No other, because it doesn't say plus minus 1. Then real quick on 1/2. By the way, what does that make y equal to? If I have 1 for x and 2 for r, what is y equal to? No, we got to remember our either 45, 90s or 30, 60, 90s, what I've been writing down about this. Okay, what's 2 squared? We're going to go back to January. What's 2 squared? What's 1 squared? What's 4 minus 1? What's the square root of 3? Square root of 3. Okay, then what does that mean your reference angle is? This is where we got to get. We got to get here, guys. What's our reference angle? What's opposite root 3? 60. Now, where's cosine positive? In quadrant 1, I'll take care of that one. What's the other quadrant? It's positive. It is 4. What's the 60 in quadrant 4? Nope. You just got to do 360 minus 60. 300. Okay, so we got to get used to these and fast with those. And now look at our directions. This is what I did. I got those answers. Now I got to do this. I'll do this one because I introduced this last Friday, I believe, too, as well. The problem with all 3 of these answers is there's no relation. There's 60 in quadrant 1 to tie these together. So I don't have a distance here that's equal to that even. So it's actually easy. Actually, I'm not even going to write 0 degrees plus. I'm just going to write the first one as 360n. Because what happens when I plug in 0? What's 0 times 360, everybody? 3, 2, 1, go. 0. Then I plug in 1, I get 360. I plug in negative 1, I get negative 360, which still lands me in that first position. This is not new doing this idea. We did this with asymptotes. And then because 60 and 360 cannot be condensed into one answer, you just go ahead and add. We still have a little bit of pickup on this pen. It did get a little worse, but maybe I'm sliding it too much. You just tack a 360n on to each one of these to name all the angles that would equal this within, that the magical coordinate plane that we have there. Okay, so the next person, all right, we're gonna get you, man. You gotta have a. There we go, Carolina. You got yelled at Friday as well, Carolina. All right, 12. Didn't we make the movie Fifth Hour on Friday as well? All right, just who ended up happening there? Sorry, 12. Who's 12? No one else is absent here. 8, 9, 10, 11. Nice, Evan. What's sine of theta equal to here? By the way, Evan, don't answer that question. Did you know on Tuesday, tomorrow, bring your Chromebook, I will have this will be the question on Friday. I'm sorry, on Tuesday. I'm getting my days all screwed up. Because all tomorrow is going to be is you're just going to have to factor. By the way, what would this be called? A different. We're running out of time. A difference of two perfect. A difference of two perfect what? Squares, and then it factors to be one square minus the other square, one square plus the other square. I'm just telling you what's going to happen tomorrow. Today's Monday. Those are the parentheses you get. Tomorrow, we're just going to add that you have to factor, and then maybe some other things are going to happen. Okay, but what sign of theta equal to? 1/2. So again, the zero product property just says if something times something else equals 0, then each part of those products can equal 0 or do. Didn't say that very well mathematically, but that's the truth. This is the zero product property that we used actually very vigorously in chapter 2 of last semester. All right, so that's why I'm going over this fast. And then actually you should be able to get these pretty quick because they're all the same reference angles. What are the reference angles? They're all 30s. And you should be able to say that because how many times have I asked you sine of a 30 when you walked in? What does that equal? And you tell me the answer is 1/2. So actually this is a 30 in 1 and 2. See, we're still getting this pickup here for this one. And then 3 and 4 for this one. So go ahead and tell me what are all those angle measures. 30, 150. What else? 210. Yeah, we're getting this jerky pen thing. And then what? 330. There it is. Connect, connect, connect. That is from 0 to 360, those directions. Okay, now let's get somebody else. 11. Nice. Matt back there. Let's do all. But before you do that, Matt, how far is 30 and 210 away from each other? So I could write that in one way for those two. What can I add to 30 that ends up hitting 210? And then what do I put on that 180? Yes. This is why this one's a little different. You got to do a little bit of thinking. Unfortunately, 30 to 150 and then 150 to 210 is not equal. 30 to 150 is 120 away. 150 to 210 is only 60 away. So I do have to kind of separate these into two different chunks, I guess. What's the other chunk going to be there, Matt? Take that chunk and do what? 150 plus 120. Oh, how far is 150 and 330 actually? It's the same number as how far 30 and 210 are away. Oh, 180. I don't know why I thought that was 250. Okay. I was just trying to assess why you said that. Yeah. Okay. All right. So that is all answers. So we decided to incorporate that in this set of notes here. The idea of all. All right. 245. Nice. Okay. Valuable to go over this one because this does happen sometimes. 15. Wait. It's 15, 17. You? Yeah. Nate? Okay. All right, here we go. Okay, so tell me the two equations. What do we got here? Secant. And no, you cannot divide both sides by secant. So what's secant of theta equal? Secant of theta equals zero product property. I don't have anything with this. So secant of theta equals, oh no, so the zero product property. And then what's the other one? Secant of theta equals what? You add 2 to both sides, so you get 2. I'm not writing this step because I'm assuming we remember the zero product property from freshman year, sophomore year, junior year, and then us in senior year from our August stuff. Okay, so we're setting those equal to 0 because of the zero product property, then balancing the equation. By the way, 0 over... What's 0? What letter? R. And then what's 1? X. Got any problem with this? What's that? You got any problem with this? With this ratio, this R and this X? You're all right. Everything's right so far. Is there any problem with this? So you have a radius of 0 and then an x value of 1, or a hypotenuse of 0 and an x coordinate of 1.
So it would be on the 5.
This is not possible, or you'd say no solution. So that doesn't always happen, but for secant and cosecant, those can't equal 0. All the other ones can. We even had on our thing tangent of 0, I believe, on our game today. And then, by the way, 2 over what number?
1.
1, and then what are the letters?
R and X again.
And then what does that mean y would have to equal? Because that's really the key.
3.
So what does that mean our reference angle is?
60.
So it's a 60 in quadrants, 1 in who? ASTC for those that are. So first of all, it's quadrant 1, so I'll get that out of the way. Oh my gosh, this is really getting me. Okay, so theta is equal to 60. That's the 1. And then what's the 4?
300.
Okay, so we have a no solution for one part. These do, but the overall, this does work because when I plug those in to the original, you get 0 times the number, and that would still give me 0. So these still are solutions, even though the first part does not have one. Then let's see if we can get this out of the next person. 7. Nice, Ella. What are all the answers? Can I tie this into one answer, or do I have to do 2 separate ones? Is really what we're seeing here. Okay, so 60 plus ain't no thing. We don't even make it right. The end has to be an element of integers. 0, 1, -1. What's the other one? You got an easy one. And no, you cannot add these together. Those are not like terms. This is a little tack on to circularly keep hitting that same angle measure forever and ever. So this is yellow, 0 to 360 answer. This is blue, all answers. That's the difference between the two. Quick question. I don't know what else to say other than here's 60, here's 300. These are not an equal distance away from here to here, so I have to do 2 separate answers. Now, why am I doing a 360N? Here's 60 degrees. Here's 420 degrees. Doesn't that land in the same spot? That's 360 plus 60. 720, I got to do math. Plus, here's 2 rotations, 1 rotation, 2 rotations, and then 60. That's 780. 780 also solves this equation because it lands in the same spot. It is the same triangle. How often can I do this, guys? How many times can I do this? Starts with an I. Infinite amount of times. So that's why to list all answers, it's all of the angle measures that land at 60 degrees. That comes from adding a 360N on there, where N could be any integer. Same thing happens with 300. Why couldn't I put it all together? Because they're not equidistant one way or the other, all right? But these are 180 away from each other. The middle ones, 30 to 210, are 180 away from each other. So these, when I keep putting numbers in for N, land here or here, here or here, here or here, here or here. You're stuck in a cycle of landing in those positions. So that's what you have to be able to incorporate at the end of this. Be careful of tan. 14. Nice. Who's that randomly? He gone. Wait, 8, 9, 10, 11, 12, 13. Oh, 14. I thought it was him. Kick that desk right there. All right. Tan of theta equals, we're doing radians now. I think it should say x, by the way, but anyway. Tan of theta equals 1. 1 over, by the way. And then what does that mean r is equal to? No. Again, 1 squared plus 1 squared doesn't equal 1 squared. Got to have a little thought about the Pythagorean theorem, and it's one of these special triangles, huh? Root 2. So what am I dealing with? So I have a 45 in which quadrants? Maybe I'll stop and get each one done. Where's tangent positive? 1 and 3. Okay, let's just finish it off. What does that mean in radians? I don't think I did all the answers on this one. It's 1 and 3. So what are the radians? Over what's? So what's the quadrant 1 over 4? I always love answering that. People go like, oh my gosh. And then what's the quadrant 3 1? Sorry. Yeah, the pen is really getting bad with this hiccup here. What'd you say? Sorry. 5 pi over 4. Oh, that almost sounded fake. It was like halfway, and I almost lost it, but I tried to force it. So it's kind of weird. And then no, we're doing them both. So what's tangent of theta equal to? This is a good one. Good thing we had a really good student that last hour that got this right. I was like, oh, you're right. So first of all, I'll do the math. What do you end up getting? What over what? So yes, it's 3 over root 3, which you said is 3 root 3 over 3. But then what happens to the 3's? No. We add and then divide. So what happens to the 3's? So it's just tan of theta equals root 3. This was a jerky question to still get down to this, and then you'll be able to associate what you really have. What's root 3? What letter? It's over. What's opposite root 3 always? So you have a 60 in the same quadrants, 1 and 3, because it is positive. So what are the 60s? I don't know why I'm writing over 4. That's a brain mishap. You said over 3. I was writing over 4. I don't know why. But then you said 4 pi over 3, and I wrote a 4 when you said 4. I'm just telling you how my brain worked there on accident. Okay, so that is correct, and that is good. And then here we go. Student number 11, 14, 13. That is you, and I was glad. Wait, that's not you. Oh, that's you. Wait, 14, 13. That's you, Matt. Sorry to wake you up over there. Kid's snoring away here. I got to wipe the drool that he's putting on the desk right now. All right, so Matt, how far away are these questions? How far are those away from each other? Over 4 pi over, which is how far away? Pi. See, when you look at this, here's pi over 4, here's 5 pi over 4. That's pi, that's pi, that's pi, that's pi. So they are equidistant to each other all the way around. You're still crinkling those eyes. I was hoping that you would be the one to get picked on this. So what's the overall answer altogether?
Pi over 4 plus pi n.
Correct. Pi over 4 plus pi n. Is the bell going to ring on me?
Yeah.
Holy crap. And then the other one is pi over 3 plus pi n. Oh my goodness. Okay, then for movie purposes, how do you get rid of squared? What do you do to both sides? Say it right here. Square root. And then what do you have to put on the square root of 1/2? Plus minus. Don't be easy on my door. I know you want to get out of here super fast. Square root of 1 is 1. Square root of 2 is square. Hey, by the way, what's the reference angle as you walk out of here? It's not a 60. It's not a 30. It's a 45. You seniors are killing me. All right, and then it's every single 45 because in positive is quadrant 1 and 2. Negative is quadrant 3 and 4. So I put in this set of directions just over 0 to 2 pi, so it is all the over 4s. Pi over 4, 3 pi over 4, 5 pi over 4. Where did I lose my time? 7 pi over 4. We did a little quizzes before this to test those kids. Then I guess for fun, I'll do this one. Yeah, in the middle, I'm taping square root on both sides. Oh, no, you're fine. Plus minus 1 over 1. This is x over y. So what's r equal to? Actually, root 2 when you do the Pythagorean theorem. These are, again, all the 45s. Boom shakalaka. All right, so that's over. Let me make sure I didn't rush that. 1 squared plus 1 squared is 2. Square root of 2 is r. That's your 45s. That's how you do it. Okay.